Hi everyone, this is Menzies-Ye and my Swinburne student number is 1013183993, and today I'm going to go through the custom program I've written for this unit. It's a game called Osmosis, and that was the title screen. And now I can choose the skin. Basically, it's a function that returns a bitmap for the player, and when I start the game, and now I can move the player around, the character around with the keyboard, and as you can see, the player and the 10 enemies both have their own different sizes and osmolarity. That's the point of the game, and here is an ATP molecule. After picking that, I can move a lot quicker. Yes, about the osmolarity, they're actually represented by the color of the ring around the cells, and the closer you are to the purple end of the spectrum, the higher the osmolarity, and if you have a higher osmolarity, you can drain the liquid from the other cells. And to achieve the game, to achieve the goal, which is to become the biggest cell on the map, and I just level up from level 1 to level 2. And as you probably have noticed as well, that the salt blocks come in different colors. They have different values to add to the osmolarity, and it's using an enumeration. And also this game has a high score function that utilizes the C language's file I/O system. So even if the game has been exited from, the high score is still going to remain there. And we're going to also look at a hidden feature here as well. So the hidden feature of the game is that once the player hits 10,000 points, the game is going to reward the player an extra life. And the same thing is going to happen also at 25,000 points. So that's coming up pretty soon. You can hear that. Yes, that just happened. Yes, so that's the hidden feature. And as you might have noticed that as we level up through the game, the players start with lower radius and osmolarity, whereas the enemies start with higher osmolarity and larger size. So that's just to make the levels more and more challenging. So I did come across a couple of problems in the process of developing this program, and the first one was about collision detection, because I first used bitmap collision to detect the cell collisions, but because the bitmaps were already scaled before they were drawn onto the screen, so it was just very inaccurate. So what I did was to add the circle structs to both the enemy and the player, and then use the circle-circle collision to detect the cell collisions, and then that was problem solved. And another thing was about the timers, because I needed multiple points in time for the items to be randomly generated. So the Swing Games timer just didn't quite work. I used the C language's time.h library and got the starting point of the game, and further into the loops of the game, I got the current time, work out their difference. So every 8 seconds, there is a salt block being generated if it's not already on the screen, and the same goes for ATP molecules. So that's it. Thank you. In the process of developing the game Osmosis, I used to use functions to randomly generate between 0 and 1 in order to determine in which direction the enemies should move. And in the end, I realized that there were way more zeros generated than 1, so that prompted me into doing a little bit research into randomness. And after reading extensively online, I realized that computers and algorithms are very deterministic in nature, and due to this nature, the random numbers they generate can only be classified as pseudo-random. That is to say, they are not really random, because the algorithm would take in a seed and then churn out an outcome, but that is totally predictable. In this case, it's not even good enough for the game, so it certainly is not good enough for encryption or other scenarios that require high-quality random numbers. So the essence of randomness is to introduce entropy into the process. That is to say, introduce real randomness into the process. And some people would actually go about using hardware-based random number generators, which would utilize the atmospheric noise or voltage on a particular electric component at a particular point in time to generate those random numbers. Or if we are actually not purchasing those devices, we can still use elements such as seconds since the Unix epoch to introduce some entropy into the process, because we don't really know when the user is going to execute the program. That's the element of randomness. And as we can see on the right side, if we don't seed the srand, or if we seed it with 1, the outcome is always 7. And if we do seed it with the second since Unix epoch, the outcome is different every time. And that concludes my little research into randomness, and it has been Leo Ye. Thank you very much.